Yes, you can be depending. Swati, 90.
Okay, hope I could you could able to see my screen, right? PPT being displayed. Okay. Suppose if you face any difficulty, whether if you couldn't able to see my screen means, please you can unmute and you can tell. So in adjacency matrix, I have given you the graph. Okay. So this is undirected. Hope everyone you might have got this. You might have put this matrix column, rows and columns, and weightages also you might have given. Any doubt in this? Is there any doubts, or if you couldn't able to create the table of columns matrix, if you couldn't able to create means you can ask me now. So if there is no doubts, then we can proceed to the next. Any doubts? You can unmute and tell, or else we can move. Okay, hope you might have got cleared. Also, video further now, if you want to go through it, videos also I have uploaded. Also, this video also I will upload it. Okay, so that you can go through the lecture videos and you can clear the doubts. Okay, and the next the same adjacency matrix, the same concept. Okay, so here next is weighted graph. So here graph is being given and the weightage is also being assigned based on the either it can be based on the priority or based on the frequent of informations that is being accessed. Okay, so based on that weightages also can be given. Okay, and if you see this weightage of graph from A to C is 7, then A to B is 5. Okay, so for each each nodes, okay, numbering or the serial number is also be given for A0, B1, then C2, D3. So here every information is being assigned or weightage also being given for each nodes and the edges links. Okay, so based on that matrix is being given 0 to 7 and 0 to 7. So 0 0. So there is no self iteration, so it's 0. So instead of 0 you can put the infinity. Okay, so this simple you can give. Okay, and then based on that when you go through every x and y axis, so when you go through every matrix you give the weightage and the remaining you can give it as either dash or this infinity. Okay, so this is how based on the weightage you can create a matrix and then you can assign the weightage for each matrix representation. And so for weighted graph, so here a graph is being given. So I hope now you can give the you can draw the matrix. Okay, 0 to 0 1 2 3 4. So 0 to 4 x-axis, 0 to 4 y-axis. So you can form a tabular column, matrix column, and then based on the weightage you can enter the values. Null you can put it as 0. So if there is no weightage given means you can put it as 0. Okay, so this is undirected graph. Okay, so 0 to 0 0, 0 to 1 is 2, then 0 to 3 is 0 to 3 is 0. So there is no weightage or there is no communication path, means automatically it will be 0. Okay, so here 2 to 1 is 15. So 2 to 1 is 15. So based on the weightage you assign the values and then you can see how which matrix it has the more weightage. Okay, and then in adjacency matrix also we worked with undirected. We have worked with undirected graph. Then directed graph also we have gone through, and also we have also gone through the weighted graphs. So weighted graph means graphs is being assigned with some weightage points. It can be based on the real world scenario also. For example, if you take if you want to travel from one place to another, for example, you take from Chennai to Delhi, okay, and you put each node as train, okay, different train names. So now you can put the weightage. If you put from 0 to 10 weightage for every trains, so now you will put, okay, for super fast train you'll put one kind of weightage. For local trains, if it is normal train, if it is express means you'll give one weightage. So based on the nodes you just assign the weightage, and also if you see overall you can able to find out which has the highest weightage. Okay, so that what when we take this adjacency matrix we can work out with directed, undirected, and the weighted graphs. And here also some points or can also be assigned. So here a graph with undirected graph is being given, and from there we just take out with different matrices. Okay, based on the edges we assign different matrices. Okay, and also here we see which has the highest weightage. Okay, and also we could notice that each edge points, okay, you take all the zeros and put only the weightage and see which rows and columns or which matrix it has the highest weightage, so that you can find out overall value for this adjacency matrix. Okay, and the next is ways and modes. So already definitions we have seen ways. Okay, so when you take a ways, it comes out with possible clusters. That means possible means of traversal within that particular component. Component means the entire graph. Okay, so when you take adjacency matrix of a graph, it will be always a square shape. That means if it has 4 nodes means we have 4 cross 4. So totally it comes under the square. Okay, also it has the same number of rows and columns. It is a one mode matrix. It starts with one mode matrix, and it can come out with based on the nodes we can also fix the the nodes. Okay, so if it is a one mode means, see here rows and columns, the rows will be with one parameters, and columns also will be assigned with another same parameter. So that is one mode. See here A, B, C, D, E, F, rows also that can be measured with same parameter. But if it is a two mode means two different parameters, P1, P2, P3, P4, and E1, E2, E3, E4, E5. Okay, so in some cases, no, we just work out with one mode matrix. But if you want to calculate with more than one parameter means we go with two mode matrix. Okay, for example, now marks, your marks and grade. So marks that can be in one column, and grade you can have it under one column. So if the mark is 45 means grade can be what C grade or P grade. If it is above 95 means you can put marks under 95 and grade as this. So that you can measure under two mode. In some cases, you have to measure only under one mode. Okay, so these are the ways that can be measured with the number of ways of modes. Okay, and then when you take ways and modes, okay, so here you can see the ways are the dimensions of matrix. Okay, so here you can see the different layers. Okay, so which has different entities. So different layers are being grouped under one matrix. So this is one mode, and ways is under different modes. Okay, so this modes can be represented under different ways. So here it has been grouped, layers has been grouped But in Waze, every layers has been divided into number of discrete chunks, and it is being splitted so that it will be transparent to every other every other network that may access this particular cluster. Okay, so this is the main aspects between this Waze and the modes. So the Waze can be the dimensions of matrix, while the modes are the different types of entities or different layers of that particular entities that can accommodate and as one package. Okay, so that is the main important aspects of this Waze and modes. So this is a matrix product. So with a matrix to create a product. Okay, so two matrices are being given. So from that every matrix, how will we create the product? So this is a mathematical calculation. So in this, so here two rows are being given as one matrix, and two columns are under another matrix. Okay, so we multiply each row under each column. Okay, so when we calculate, we get one value. So that value will be the outcome of the matrix products. Okay. Okay, so here an example is being given. You can go through this example. You can take this example, or you can work out with your own example also. Okay, with the concept of matrix products. Yes. So I hope mostly we have covered all the topics under this Ways and modes. So concept I have explained, and here case study is there, so you can go through every case study. So example case study is being given. So if F is a friendship relation and B is a boss of relation, then if one have an FB relationship with Jane, okay, she's a boss of at least one of my friends. So this is one case study. So you read out the case study, and then you can also create one matrix, then you can work it out. Okay. Next, we'll move on to the second module. It's some research methodology that is being related to this graphs. Okay, so here some how we can able to work out with some research design concepts using the graphs. So here in graphs we have seen many strong ties. We have seen that keywords, strong ties, weak ties, ways, modes, adjacency matrix, then directed graphs, undirected graphs. So many formulations we have made. So based on the research, how we can able to implement these in different platforms, whether in medical side, what kind of graphs we can use, or in statistical analytics, what we can use in agriculture aspects, what we can use in energy, food, in water and energy. So in these research level, how we can able to implement these parameters in their particular platforms. Okay, and this is a list, and here there are different studies that we can able to formulate. One is cross-sectional and longitudinal studies. So when you take the cross-sectional, see here, it will be what in general we tell it like a MOU. We sign an MOU with different organization or institutions. Okay, the same concept. When you take this cross-sectional study, we have a broad-minded, in-depth knowledge of every multi level aspects. Okay, so with group 1, group 2, and group 3. But when you take the longitudinal study, okay, within same group we just analyze in depth, or we extract the in-depth knowledge within the same group. Okay, so here see group 1 time 2 time 1, group 2 time 2. That is, time 1 can be for if it is for 1 year or 2 year, and time 2 can be for 2 years, or time 3 can be for 3 years. So every year we work with the same group and finding out the possible how many nodes we can able to work on this, and how many links we can create within every nodes. Okay, so that is working with same group. So that is a longitudinal study, and cross-sectional study is working with different groups compared at the same time. So same time different groups, but in longitudinal study same group compared with working out with a different group. Okay, sorry, same group under different times. So that is the main difference between the cross sectional and longitudinal study. So when you see the differences, in cross sectional, one point in one time, several points in one time. When you take cross sectional different samples, we can able to work out, but in longitudinal only same sample, and cross sectional snapshot of a given point in time, that change at the societal level. Because when you take the societal level, we will be having a number of broad knowledge, broad minded people will be discussing, and will be collecting more information, so that more different types of outcomes also can be expected. Okay, so that is the main difference between the cross sectional and longitudinal. Also, when you now you're in third year, when you go for final year projects, better if you work with cross sectional, interdepartmental, if you have a collaboration with other departments, implement the agriculture concept with agriculture, implement the machine learning concept with agriculture, or deep learning concept with the medical field, deep learning concept with the food. Okay, deep learning concept with the energy, water. So you can have a cross sectional study, so that you can have a broad mind on every areas. Okay, so here experiment and field studies is also being given. You can go through this field study, and if you like to have a small experiments, yes, you can work it out. Also, we can have under for your quality assessment also, you can take this case study and work. Okay, and here we have two methods of experimental field studies. One is quasi-experimental research, and the other one is observational studies. So when you take this quasi-experimental research, so there is pre-post design. That means prediction. Okay, we can predict, and we can analyze, and we can tell that this can be one of the outcome of this particular independent variable. Okay, then observational studies, take some samples, work on it, and get the output, confirm that yes, this is output, and this is the network connectivity, so this is a strong entity, this much is a value for the weak entity, so that we can go wherever we have the strong entities, we can utilize that network, or we can utilize the nodes or the people who are connected within that particular network. Okay, so these are the main research study, how we can implement whatever we have learned in the chapter 1 and 2. Here you are going to have an in-depth knowledge from each areas. Okay, and then whole network and personal network research design. So I don't want to tell much about this. About whole network, considering the inter-network and the personal network. Okay, so you know what are the advantages in whole network and what are the advantages in personal network, and also the disadvantage of whole network and the personal network. Okay, everyone knows all informations, criterial expectations from the whole network. Whole network, it consists of the entire scenario. Okay, it's a broad area, but personal network means your own, which has some limitations. Okay, so when you take a personal network, which is called as a egocentric, it affects, it has an effect on social context, on individual attitudes, individual behaviors and conditions, collect data from respondent. So that is a ego, his own informations, his own one and only, so they tell like that. Okay, but when you take the whole network, whether it is complete or it is sociocentric network analysis, it goes out with the interaction within a socially, geographically bounded group, and also they collect data from group members about the ties to other group members, with the selective social setting also. Okay, so here see the picture. So when you take the whole network, every networks are being tied up as one cluster. But if it's the ego means small network, they have their own centric nodes. They decide what has been planned. Okay, they don't have or link with one cluster with another cluster. So there are many. If more advantages there, some disadvantage also will be there. Likewise here also. Okay, so based on the what we can tell, like we can tell like based on the scenario. Okay, you can decide whether you can go with personal network or you can go with the whole network. Okay. So whatever I have explained, so here there are some case studies also being given. Okay, whole network designs, every enable designs and enable the researchers to employ the full set of network concepts, and also the techniques they will be learning on different parameters, working with different data analytic concepts. Okay. And next is sources of network data. So what are the sources of data elements that you can able to acquire? One is that through the primary data collection, and second one is the secondary data collection. So there are two modes in which we can able to extract the information. Generally we tell it as social network analytics. Okay, so when you take this primary data collection, we directly ask people, we ask the questions, we take one survey paper, give it to them, and they fill the form. So through them, now we can collect the data. But when you take the secondary data collection, we gather data that is already predefined, already existing somewhere else, whether it can be in data centers or whether it can be in any other records or whether in any hard disk or things like that. Okay, like historical here examples, few examples also being given. Then electronic databases. Okay, secondary data, it can be collected. When you take historical data, it's not very simple. It's very difficult, and it's very hard to maintain all these secondary data. Okay, but primary data is like now and then whatever data we collect within some particular sources. So likewise, when you look into the network, when we take cloud computing concept, nowadays people, they are working on edge computing. So next level of cloud computing, they work with edge computing. And so when days goes on, people, they want to know by less utilization of resources, how they can able to manage the entire things without internet connectivity. Okay, less usage of internet connectivity, less usage of manpower, how we can able to establish or how we can work on these problems. Okay. And when you bring the nodes and ties here in this category, okay, and different categories of informations are being expressed here. Take co-occurrence on category. So where we can collect the data from co-membership groups, co-participation in events, physical distances, similarities in attributes. So these places, we can able to collect the data. Then social relations, kinship relations, and affective relations, perceptual. So these are the categories, and these are the platforms where we can able to or modes where we can able to extract the data informations. Okay, through this network platforms. Okay. And then so here there are some case studies are also being given. Please go through it. So actor, so what I have explained now, actor attributes that comes out with the nodes working with or extracting the data information from each node available in that particular network. How they communicate with other nodes and how they extract the information. So, for example, you take the service providers like BSNL or Airtel or Jio. Okay, so they no they themselves know they'll be having some mutual understanding. Okay, so if I want to have better connectivity for my service provider, means I just have some MOU with the other service providers, so I use their infrastructure to implement my resources. Okay, so that is how they have some collaboration among themselves. Their main attitude is their product has to be established by using some other ways, means. Okay, so that is other main establishments where we can work out with every actor or every individual nodes when they connect with all some for example is either service providers or through any work bound areas. Okay, so this can be another one part of that particular component. Okay, and then next one is the sampling or and bounding. Okay, so when you take the concept of sampling, no, the name itself it denotes like sampling. Okay, sample having some or extracting some important no either it can be nodes or it can be informations from a group. Okay, so in sampling itself we have another one type, random sampling, snowball sampling. Okay, so then census is also another one kind of sampling. Okay, so when you take random sampling, no, they pick the people randomly, either through any algorithms. Okay, how they can work out with the random sampling. So this and all algorithms you can work in your projects also. Okay, so how do they extract the informations, through what means, whether when they work with random sampling will they get the proper output. Okay, or when they work with snowball sampling, how will they get the proper output. Okay, so when you take this random sampling, no, it comes out, or they work with the persons matching the researchers criteria. So I will be having one criteria, and based on that criteria use the a random sampling concept and extract the data informations. Okay, so from every individual, from a group of population. And then snowball sampling is it is being related to the snowball games. Okay, so here a goalkeeper will be there, then the next level of persons will be placed near to goalkeeper, and again there will be a clusters, or the persons will be placed in different locations. Okay, or you take the football match, football match, how the position should be. Near goalkeeper, how many persons should be there? Next to that person, how many persons can be positioned? So this is the concept of the snowball sampling. Okay, how the people can be diagnosed, and how they can make based on their skill sets, or based on their working sort of skills, they will be allotted in that particular areas. They will be positioned. Some will be so much expertise in what tackling the situations, so they will be placed in one. So this real-time concept we have to match with the network. Okay, so in network, so one can be the admin. So under that, two admin will he'll have a sampling of two other nodes. So under that nodes, some other clusters will be connected. So that's what they relate this sampling concept with the snowball games. Okay. And there are some of the pros and cons of the snowball sampling. So the main advantage of this is there is a chain referral process. That it's like a hierarchy. So from main, sub, and it comes like that. It's very cheap, simple, and cost efficient. And some disadvantages: little control over the sampling method is that. So they cannot move themselves. The network cannot be splitted by itself. There is some control within that particular networks. Okay, and there are some representatives. That means, as I told, no admin will be there. So because of that, they cannot design the, or they cannot confirm the entire network strategy. They cannot increase the network infrastructure. Okay, so that is the other main disadvantage of using this snowball sampling. And then next is census. Okay, all persons matching the research criteria, they just expect, and they retrieve the information based on the interest, node connectivity, or as we have discussed, strong ties and weak ties. So if there is a strong ties, means yes, you can categorize the strong ties nodes under one category and weak ties under another category. Okay, so when you compare this, so next is survey. Okay, so when you compare the census and survey, okay, so we'll see what is census collect information about every member of that particular population, and survey collects information from sample of that population. Okay, census is more detailed and accurate. What is survey? Survey is not accurate, or it's not a reliable as the census. That means census, they pertain that yes, it can be implemented, but survey is, they get overall information, but they don't come out with the accurate value. Okay, census is generally conducted by the government. Surveys can be conducted by anyone. Yes, census are not conducted frequently. Surveys can be conducted more frequently because it's a small group. They can have survey, and but census, it's overall criteria, and individuals cannot make it. Okay, because they don't, individuals cannot collect the data as a whole, but only government and higher officials, they can retrieve the data as a whole. So that is the main aspect. And next is strategies for finding group boundaries. Okay, so this is required parameters of each network scenarios. Okay, finding out group boundaries. So you can assign some limitations. Okay, how will you set the group boundaries? Whether based on the sampling method or census method, or so, whatever method you use, but strategy you have to implement. Okay, also you can solve this. Some research studies, they use the concept of nominalist criteria and realistic criteria. Realistic means however it has been happened, based on that they work out. Nominalist means prediction based, they can able to work out. So here nominalist criteria, exogenously identified conceptual population boundary. Okay, exogenously identified. Okay, based on the proved. Realistic means it's mutual subjective perceptions of actor. Okay, whether it can be done or not, they can get from that particular node itself. Okay, and some of the data reliability and validity issues based on the network. So already we have gone through it. Okay, sources of data reliability. So based on already we have gone through few algorithms, and if you take a survey or census, okay, we should see about the data reliability, whether the data's if you take data reliability based on census, if you categorize census and survey, you take data reliability, how this can be placed in both the areas. Okay, survey is no, we cannot ensure that you can have that much data reliability on survey, but in census, okay, the percentage can be increased. Okay, when we compare to the collection of other types of data in the social realm, okay, the network data in the social scenario will be like quite challenging, because every people, they have a number of connections, a number of links, contacts will be higher. There will be strong ties. Weak ties, yes, we can somehow we can adjust, but when you take the strong ties, it's it will be one of the challenge. Okay, yeah. So with this, we'll complete. So this is your so end of this third chapter.